In this video, we're going to be studying arcs and chords. We are currently studying circle theorems for this unit. If you find this video helpful, share, like, and subscribe. Arcs and chords of a circle. Let's look at some terminology and labeling. So let's look at the word chord. Chord. Line segment connecting 2 points on a circle. Okay, so here is a circle in here. So we're going to create a chord. It says that it's actually a line segment connecting 2 points on a circle. So I can create one from here, 1 point in there, 1 point in there. I'm going to create a chord like that. So we can also have a diameter. So we say in here that diameter is actually a special chord that also passes through the center of the circle. This is also known as the longest chord of a circle. Okay, so we're going to create a diameter. So from 1 point in here and then to another point, and I'm gonna connect, and it's going to pass through the center, and that is what you call our diameter. So here I'm going to say this is diameter and this is our chord. Okay, so I would like you to take note of something in here. Note that every chord must touch the circle twice. Okay, here I would like you to look at that part. Circle twice. So let's look at some theorems regarding arcs and chord. Okay, so the first theorem simply says that congruent central angles have congruent arcs and chords. So the keyword in here that we're going to be looking at is actually the word congruent arcs and chords. Conversely, congruent arcs, keyword again, congruent arcs have congruent central angles. And converse again, congruent chords have congruent central angles. Now, let's scrutinize this theorem. In theorem number 1, they are simply saying that congruent central angles here, this is our central angle in here, have congruent arcs. Okay, so our arcs in here is going to be this part here. This is our arc. Now, the converse is simply telling you the other way around also. It means to say that if you're going to start from the congruent arcs here, if you're going to start from the congruent arcs, then the result of that is that they're going to have a congruent central angle. Now, another thing that I would like you to look at here is the last converse. Since here, congruent chords have congruent central angles. Okay, so if you're going to be looking at this picture, it says that congruent chord. Okay, here we can see that this is congruent. It means to say that they also have congruent central angle. Okay, let's continue with the second theorem. Okay, here the second theorem simply says that within a circle or in a congruent circles, congruent chords have congruent arcs. Keyword, congruent chords and congruent arc. In here also, that within a circle or in a congruent circles, congruent arcs have congruent chords. Okay, so let's look at our diagram in here. So it says that congruent chords have congruent arcs. So let's recognize our arcs in here. So I can see arc, this is one arc, and that's going to be congruent with arc CD. So we can say that line segment AB is congruent with line segment CD. Therefore, we can also conclude that arc, this is the arc AB is actually congruent with arc CD. Okay, the third theorem. Okay, the third theorem says that chords equidistant from the center are congruent, and converse, congruent chords are equidistant from the center. So if you're going to be looking at chord AB and chord CD, we can say that they are actually congruent because they are equidistant. Keyword is equidistant from the center. And its converse is also true, that congruent chords are equidistant from the center. So we can say that CD, line segment CD and line segment AB are congruent because they are equidistant from the center. Okay, theorem number 4. Okay, this theorem talks about if a diameter is perpendicular to a chord, then it bisects that chord and its arc. Okay, it's really very self-explanatory because the main subject here is the diameter. So it's telling us that if the diameter, okay, is perpendicular to any chord, okay, in this case we can see that the chord in here is CD. Okay, so our conclusion here is that if that's the case, then it bisects the chord. Okay, look at the C. It actually bisecting that chord. They are intersecting at E. And what does it say? It's going to bisect its chord, that's correct, and also its arc. These are arc CA and arc AD. It means to say that these two arcs are congruent, in as much as these arcs are also congruent. Okay, let's go for the next theorem. So the next theorem tells us that if a diameter bisects a chord that is not another diameter, then it is perpendicular. Okay. So let's look at this diagram. So it says this, okay, the subject again here is diameter, and the keyword is bisecting a chord. Okay, but this is not another diameter. It means that there's only one diameter in here, and there's going to be another chord that's going to be bisecting that diameter. Our conclusion in there is that these two are perpendicular to each other. It means to say that they're going to create a 90-degree angle here. These are the 90-degree angles. There you go, and also this one and this part. Okay, the theorem number 6. Still, we are talking about the perpendicular bisector in here. So it simply says that the perpendicular bisector of a chord contains the center of the circle. Okay, so it means to say, simply said, that it's talking about the diameter. Okay, so the chord is also a diameter, and within the diameter we can actually find the center of the circle. Okay, simply said, that's actually the very simplified version of this theorem. Okay. Let's see some example in here. So in here we're going to find the segment measure in a circle. Example number 1, what is the value of x? Okay, so if we're going to be looking at our theorem once again in here, so we can say that this situation is actually falling under theorem number 3. So it talks about congruent chords that are equidistant from the center. Okay, going back to the problem, it says what is the value of x? So if everything is equidistant, it means to say that this segment should be equal with this. It means to say that the value of our x is equal to 16 also. So if you're going to be looking at this chord 18 and 18, that's going to give you 36, and the other chord in here is 36. Therefore, the value of this x in here is equal to 16 according to theorem number 3. Okay, so let's try this one. Try this on your own if you like. You can pause the video if you like and start working on this, and then come back again later. Okay, so what is the value of x in here? So we can infer in here that this chord is 15. It means to say that this is also going to be 15. And we also said in theorem 3rd that these chords are going to be equal because they are coming from the center of the circle. Therefore, the value of x in here is also equal to 8 according to theorem number 3. Okay, let's look at number 2. In here, what is the length of line segment RS in circle O? Okay, if we're going to look at carefully the dimensions that's been given here, so we can actually infer that this line segment PQ is 12.5. It means to say that RQ is going to be also 12.5. So that's actually gonna be around 25. So the whole length of this is going to be 25. That's 12.5 plus 12.5. So with this theorem number 3, it means to say that this line segment SR or RS is also going to be 25. Okay, so let's prove that. So we can say therefore that RS, line segment RS, is actually congruent to line segment PR. So if that is the case, then then RS is going to be equal to 12.5 and then another 12.5 here because we have to cut this part. So that's going to be 12.5. Therefore, it's going to give you a total of 25. Okay, let's go for the next. On your own, if you want to pause the video and do this one by yourself before you're going to see the answer, go ahead and do it. So here, what is the value of x in circle O? So in circle O, we can see that let's label this one. Let's say this is A, this is B, this is C, and this is D. And in the middle, maybe I'm going to say this is going to be E. Okay, and there's X in here already. So let's see, what can we see in here? This line is going to be the same here. It means to say that this is also 7. It means to say that the length of this is going to be 14. So if that is the case, it means to say that according to the third theorem, then this chord will also be equal to 14. Okay, therefore, we can say that x is equal to 14 because of what theorem number 3 has stated. Okay, let's go to the next. What is the value of x? Okay, so x in here is actually what? It's called a radius. So how many radius do we have? We have 1, 2, 3, 4, and then this 5, okay? Now, we can always say that the sizes the measurement of radii are congruent to each other. It means to say that they're equal in length. Okay, so all radii are actually congruent. Okay. So with that said, if we're going to be looking at one of these radius, that's the size is 14, it means to say that this value of x in here will also be 14 because all radii are congruent to each other. Okay, try this on your own if you like. Okay, what is the value of x in here? Okay, it's very obvious. This is again a radius and this is a radius also. Two of them are called radii. And remember that all radii's size or measurements are congruent. Okay? So from this picture right now, we don't have to think too much, but we can just simply say that the value of x is equal to 6 because x is also a radius, which is, in this case, we are given the size of the radius in here, which is 6. Therefore, this is also equal to 6. Okay, let's go to the next one. Example number 4. What is the value of x? So we can see in here that the place where x is, that is actually a diameter and there is a center in here. We can also see that this part of this radius on the other side is 8.6. Okay. It means to say that the value of x here is equal to, we're going to add these two together, these two numbers. And that's going to be the size of x. That's going to be 5.1 plus 8.6. And this is going to give you 13.7. Okay. That's very easy to look at. Okay, let's try this one on your own. Okay, so what is the value of x in here? The same like the first example we did. Now, what we can see in here is that this radius has a size of 34.8. Okay, and this is another 34.8. This is going to be 34.8. But there is a chord in here that cuts the line. And this part is actually 6.7. Therefore, the value of x plus this 6.7 is going to give you 34.8. Now, minusing 6.7 on both sides, It means to say that x now is going to give you 28.1. It means to say that this value of x is actually 28.1. Okay, let's go to the next one. Okay, what is the value of r? This time it's r, the radius. Now let's look at some information in here. Chord LM has a total of 14. So since it's going to be cutting through the middle of the circle, that's going to be divided by 2. It means to say this one part is 7 and the other part is 7. Okay, in this case, I can actually redraw this one into like this one, a right triangle, okay? So this is going to be 3 centimeter. Our radius is, we don't know, but this is going to be 7. Okay, so that means that we're going to use our Pythagorean theorem. A squared plus b squared is equal to c squared. In this case, our radius here is going to be the c squared. Okay, so let's put in the values. This is going to be our a, this is going to be our b, and this is going to be our c. So I will just put r for the c. So in here, I'm going to put 3 square. Here my b is 7 square. And I will just put r squared, okay? So that's going to be 9 plus 49 is equal to r squared. Okay, 9 plus 49 is going to give you 58 is equal to r squared. Now taking the square root of both sides, this is going to be, so r is going to be the square root of 58. Now using my calculator in here, this is around 7.6. Okay, but this is going to be the real value of our radius in here. This is according to our theorem, the fourth theorem. Okay, I would like you to try this on your own. You can pause this video if you like, then come back when you're ready to check it with your answer. Okay, so in here we are asked to find the value of y, this part. So I can see that this is going to be a radius. So if I'm going to redraw that, it actually looks this way. Okay, my y is somewhere here, and I know this is a radius also, so that's gonna be 15. And this is 11. This part is going to be 11. So what is missing there is the a part. Okay, so I'm going to say a squared plus b squared is equal to c squared. So in this case, my a is the y squared. So I'm going to say y squared plus 11 square is equal to 15 square. Okay, continuing the process, that's going to be y is equal to the square root of 15 square minus 11 square. Okay, continuing with this, you're going to actually have that's 15 square is 225, and then 11 square is 121. This is going to give you the square root of 104. Therefore, my y here is equal to what is square root of 104? It's gonna be 10.19, or if it is going to be rounded off to nearest tens, it's going to be 10.2. Okay, let's go for the next. Now, exercise numbers or example number 6. What is the value of x in here? Okay, so if I'm going to look at this very carefully, what I can do is I can actually create a triangle in this part. So it means that this is going to be 14 also. So if I am going to redraw that into a triangle just like this one, okay, so this is going to be the radius part, which is 14. This part is going to be this part, which is 3.7. Maybe I will call this side y, okay, because we have x in here. So this is going to be y. So we're going to use our Pythagorean theorem. We're going to solve for y. So in here, our y is actually the a, b is 3.7, and of course this is c. Now if we're going to directly solve it, we can say that y is equal to the square root of 14 square minus 3.7 square. Okay, now 14 square is going to give you 196, and 3.7 square is going to give you 13.69. Now we deduct that together and we're going to come up with 182.31. Getting the square root of that, the value of my y in here is going to give you 13.5. Now, this is not the final answer because that is just the value for y in here. What we can do here right now is to equate this x and y is equal to 14 in order to get the value of x. Okay, so say x plus y is equal to 14. Why 14? Because my radius has a total of 14. Now, I solve for y. The value of my y is in here right now, so I'm just going to put that in. So x plus 13.5 is equal to 14 minus 13.5, okay, minus 13.5. Therefore, the value of my x in here, 14 minus 13.5 is going to give you 0.5 or 1/2. Okay, it's just 1/2, but in here, let's just use 0.5. So if we're going to be looking at 0.5 plus this 13.5, we're going to get the size of the radius, which is 14. Okay, on your own, you can pause this video if you like and come back after you have done and check it with my answer. Now in here, let's look at this one. What is the value of x? So what I can do in here is just like what I did earlier on the first example, where I can actually draw a line in here to create a triangle, because this is going to be like the radius also, which has a total of 10.2 or a size of 10.2. Okay, so I'm going to draw a triangle in here. Okay, so this is our 10.2. This part is going to be 7.8. This one, I'm going to call it again y, okay, because we're finding the value of x in here. So y, so here we know already this is going to be our a, this is our b, and of course that's going to be our c. So shortcut, y is equal to the square root of 10.2 first, 10.2 square, we deduct 7.8 square. Okay, so 10.2 square is going to give you 104.04. My 7.8 square is actually going to give you 60.84. Okay, we deduct both, so we're going to have 43.2. Okay, I'm using my calculator, guys. Okay, so here my y here is now going to be 6.57, which is approximately 6.6. Okay, so here we're going to equate again, just like what we have done. It means to say that x plus the value of y, which we have gotten in here right now, is now going to be a total of 10.2. So x is plus 6.6 is equal to 10.2 minus 6.6 minus 6.6. Therefore, x is equal to, this is going to give us 3.628. 3.628. Okay, so if I'm going to look at its approximation, that's only around 3.6. Okay, so that's it. So it means to say that if we're going to add the value of x and a y, we're going to come up with the same size of our radius. Okay, so let's look at some more practices on arcs and chords. Find the length of the segment indicated. Round your answers to the nearest tenth if necessary. Okay, let's go for the first one. So in here, we are asked to find the value of x. Now, this is very easy because if I'm going to look at the theorem, it says that this chord and this chord should be equal. Therefore, the value of x is equal to 6. Okay, let's look at the second one. Here, it's going to be the same. Okay, so this one is going to be equal, x is equal to 3. Okay, let's go for the next one. Okay, this is very nice. So all I can see in here is that this diameter has a total length of 31.8. So if I'm going to get the size of one radius, that's going to be 31.8 divided by 2. This is going to give me 15.9. Yeah, 15.9. Now I have this number 7, there's 7 in here. That number 7 actually is a part of this radius in here. Remember that this is also a radius, okay? So if I'm going to deduct 7 in there, then that's going to give me 8.9. Therefore, the value of my x is 8.9. Okay, let's go for the next. Okay, too many numbers to see, but let's just find out what is asked in here. So I can see that this is actually a radius. Okay, this is also a radius of 9.7. It means to say that my x plus 5.1 is equal to 9.7 minus 5.1 minus 5.1. Therefore, the value of my x here is going to give you 9 minus 5 is 4, 7 minus 1 is 6, 4.6. Okay. Okay, let's go for the next one. So in here, what we can see in here is that they're asking me the measurement of x, which is part of a radius. Okay, this is a radius. So I can see that this 25.2 is the size of the whole diameter. So 25.2 divided by 2, that's going to give me around 12.6. Okay, 12.6. Now I see this number in here, 4.5, which is part of this radius in here. So it means to say that I can just subtract it. Yeah. So subtracting 4.5. Okay, so this is going to give me 8.1. Therefore, the value of my x in here is 8.1. Okay, let's go for the next one. Okay, the same problem like what we have seen earlier. So this is a diameter. Okay, so it means if I'm going to divide 18.8 divided by 2, then this is gonna give me 9.4. But I have 4.2 in here, and this is still a part of the radius. So I will just subtract that 4.2. So this is going to give me 2, and this is going to give me 5. Therefore, the value of x is equal to 5.2. Okay, let's go to the next one. Okay, they're asking us in here the value of x. Okay, so what it tells me is that this chord, one side of the chord is 10.6. It means to say that this is also 10.6. Okay, so let's see. If we are being asked for this is actually a part of your radius. Okay, so let's look at it. So if I'm going to draw it, it actually looks this way. Okay, this is. So this is 10.6, this is 4.3, and this is, I don't know here, this is your x. So what I can do here now is I'm going to say x squared is equal to 4.3 square plus your 10.6 square. Okay, so this is going to give you 4.3 square is going to give you 18.49 plus 10.6 is going to give you 112.36. You add them together, so it's going to give you a total of 130.85. Now let's take the square root of both sides. So x now is going to be 130.85. Square root of it is going to be around 11.438. Now I'm going to just approximate that. That's going to give you around 11.44. Okay, so that is the answer to this. This is 11.44. Okay, let's go to the next. Okay, this is very nice. So we can infer here that this chord is going to be the same chord in this. So this is going to be 8.3. So if we're going to redraw a triangle in here, this is going to be looking like this. Okay. So this is gonna be 4.4 and this is gonna be 8.3. What is asked in here is your x. So I'm going to go directly here. So I say x is going to be the square root of 4.4 square plus 8.3 square. Okay, you can do that. So if we're going to go further, 4.4 is going to give you 19.36. 8.3 is going to give you square. It's going to give you 68.89. Okay, we're going to add this. We're going to be getting 88.25, and getting the square root of that is going to get us around 9.39. But approximation, that's going to give you only 9.4. So in this case, this is going to give you 9.4. So this is all for this lesson about arcs and chords. If you find this video helpful, share, like, and subscribe. Thank you very much.